In this video we are going to talk about just wait a second. We are going to talk about the earth in the solar system. Okay, we are going to talk about this earth in the solar system. So why it is important? Like, we have some syllabus mapping and classification. That's some very important, so we can know about why it is important. For exam segment, it's important for GS1 paper subject like physical geography and topic reference silent features of Earth's physical geography, in which we have to understand earth and solar system basics. Okay, because this chapter is from class 6 NCERT from chapter 1. Okay, we are going to start that. So first, detailed study notes of earth and the solar system. Okay, we have two topics, earth and the second is solar system. Okay, and we are going to deal with it in one video. First thing is all about fundamental celestial phenomena in core terms. So what are the important celestial phenomena and what are the core terms that's important for this chapter? So first of all, what is celestial body? Celestial body like sun, moon and all objects shining in the night sky called celestial body. Then there's term of visibility dynamics. Okay, what is it actually? The intense glare of the sun during the daytime visually overwhelms the dim ambient light of the other stars and celestial objects, rendering them invisible from Earth's surface during the day. Okay, that's visibility dynamics. Stars, massive high temperature celestial bodies composed entirely of gases, and they are characterized by the production and emission of their own intrinsic heat and light in immense quantities. That's called stars. For example, sun star, that's nearest star to the earth. Apart from the sun, there are countless stars that like called distant stars. Distant stars, the countless stars match or exceed the sun's scale, but appear tiny and emit unnoticeable heat or light due to vast interstellar distances. Apart from stars, we have planets. Planets derived from the Greek word planetai, meaning wanderers. These are celestial bodies that lack independent heat and light, and they are lit exclusively by the reflected light of stars. Apart from that, we have satellites. Celestial bodies that orbit a planet in a fixed path, mirroring the relationship between planet and the sun. Mirror the relationship between planet and the sun. That's called satellite. Next, we have a lunar cycle and its characteristics, in which we have to answer Purnima, Amavasya, synodic and rotational logged cycle, physical surface properties, scale and distance, and historical milestone. First, we are talking about Purnima. What is Purnima? Actually, full moon. It occurs roughly once a month when the entirely illuminated hemisphere of the moon faces Earth. Amavasya occurs exactly a fortnight, like 14 days after Purnima. The dark, unilluminated side faces Earth, providing ideal condition for clear sky astronomical observation. Synodic and rotational logged cycle. Moon requires exactly 27 days to complete one orbital revolution around the Earth. It requires the exact same duration, 27 days, to complete one axial rotation spin. What the important thing is this exact same duration, 27 days, to complete one axial rotation, that's called spin, and this is called a revolution. Exact same duration, that's called revolution, and that's a rotation. The same duration, okay, 27 days and the 27 days. Consequence, this exact synchronization means only one face of the moon is ever visible from Earth. Only one face of moon. Physical surface or properties, the moon lacks conditions to support life. Its topography features mountains. Its topography features mountains, vast plains, and structural depressions. These features intercept sunlight, casting the visible shadows observed on the full moon. Scale and distance, diameter and proximity. Diameter consistently 1/4, that's 25% of Earth's diameter, and proximity located 384,400 km away from Earth, appearing visually large, solely due to its relative proximity compared to stars or other planets. Historical milestone: Neil Armstrong was the first human to step on the lunar surface on July 20, 1969. Next, we have to understand the solar system. What is it exactly? A system that bound, comprising the sun in the center, 8 distant planets, their respective satellites, and millions of smaller debris fields, known as asteroids and meteoroids. That's called solar system. Here we have something. Sun at the center. Just wait a second. Yeah, Sun at the center and gravitational anchor. There's the inner planets, there's outer planets. Inner planet like terrestrial or rocky, outer planet like gas and ice giants. Inner planet Mercury, Venus, Earth, Mars. Venus with Earth's twin, and Earth like geoid and life supporting planet. Whereas the Jupiter that has a debris rings, Saturn also debris rings, and Uranus also debris rings. Apart from that, there's a Neptune, and between these inner and outer planets we have asteroid belts between Mars and Jupiter. That's it. So first thing we have to understand about Sun. Sun's position, composition, systematic role, distance and light year travel time. Okay. So Sun की position located precisely at the center of the solar system, as we know about that. Composition giant sphere. It is giant sphere composed of extremely hot ionizing gases. Systematic role provides the fundamental gravitational pulling force that anchors and binds all orbital bodies. Provides the fundamental gravitational pulling provides a gravitational pulling force that anchors and binds all orbital bodies within the solar system. Distance and light travel time. Distance and light travel, so it's located approximately 150 million kilometer away from Earth, and speed of light like solves at 3 lakh km per second. Travel time, like despite the immense velocity, solar light takes roughly 8 minutes to traverse the distance to Earth. Next we have the planetary order and the mechanics. Distance order from the Sun: Mercury, Venus, Earth, Mars, Jupiter, Saturn, Uranus, Neptune. This is distance order. Orbital properties: all 8 planets follow elongated elliptical paths termed orbits. Planetary speeds and rotational anomalies: there's a Mercury, there's a orbital spin directions, there's a debris ring system. Planetary speed and rotational anomalies we are talking about. So Mercury, nearest to Sun, completes a single orbital revolution in just 88 days. Single orbital revolution. Okay, it's revolution, not rotation. Orbital or spin direction. While the baseline motion of the system is counterclockwise. System की motion counterclockwise है, whereas Venus and Uranus are exception and exhibiting clockwise axial rotation. So axial rotation clockwise होती है, others की counterclockwise होती है, यानी कि anti clockwise होती है. Debris ring system like Jupiter, Saturn, and Uranus feature complex planetary rings. Rings composed of vast belts of small cosmic debris. Next one, in-depth planetary profiles. Venus, that's called Earth's twin, designated as Earth's twin due to its near identical physical structural scale. That's identical physical structure scale, shape, and volume. Earth. Spatial rank, true geometry, habitability indicators, appearance. Earth spatial rank: third and nearest planet to Sun, fifth largest planet by physical volume. True geometry describes the geoid, Earth-like shape because it structurally flattens the poles and bulges slightly at the equator. Habitability indicator: the only known planet supporting life. It maintains an optimal thermal equilibrium, neither too hot nor too cold, and possesses liquid water and a life-sustaining atmosphere rich in oxygen. Appearance characterized as blue planet because 2/3, 66.7% of its total surface area is covered by water. The Pluto reclassification, August 2006. At a formal General Assembly of the International Astronomical Union (IAU), Pluto was stripped of its major planet status. It was reclassified as dwarf planet, joining other recently discovered trans-Neptunian or outer belt objects such as Sirius in 2003 UV313. Next we have minor celestial bodies. This is the first asteroid. Definition: countless tiny rock bodies that orbit the Sun independently of major planets. Localization. Asteroids localization, its locality, can do that. Concentrated primarily within the asteroid belt, situated strictly between the planetary orbits of Mars and Jupiter. Origin theory. Widely accepted as astronomers widely accepted by astronomers to be ancient fragments of a precursor planet that exploded millions of years ago. Meteoroids. Definition: atmospheric friction mechanism, and impact dynamics. Meteoroids. Definition: small, detached fragments of rock, small, detached fragments of rock moving through space around the sun. Atmospheric friction mechanics. When pulled into Earth's gravitational field, meteoroids encounter atmospheric pressure resistance. Frictional heating. Frictional heating causes them to ignite and burn rapidly, producing a luminous streak known as a flash of light that's called a meteor. Impact dynamics. If a meteoroid survives atmospheric burnup without vaporizing completely, its impact with Earth's crust creates a structural depression or crater. Galactic context and scale. The Milky Way galaxy, that's called Akashganga, a vast glowing band of millions of stars visible across a clear night sky. In ancient Indian cosmic tradition, it was conceptualized as a river of light flowing through the sky, hence the nomenclature Akashganga. Structural hierarchy. Our solar system forms a small component of the Milky Way galaxy definition, a macro system holding the billions of stars bound alongside interstellar clouds of dust and gases. The universe, found of millions of distant galaxies interacting across space. Perspective from ancient Indian astronomy. Historical scholar Aryabhat, a pioneering astronomer of ancient India, key contribution, formulated the foundational astronomical insight that moon and other planets do not generate light but shine solely by reflecting incident sunlight. Satellite typology. Natural satellite, human made satellite. Satellite typology. Natural satellite, a celestial object orbiting a planet by natural gravitational capture, the moon. A celestial object orbiting a planet by natural gravitational capture, example the moon. And human made satellite, that's artificial satellite, an artificial payload engineered by scientists, launched by rocket system and inserted into stable planetary orbits. Core function, key Indian species, like craft examples. Core function: telecom, remote sensing, weather forecasting, meteorological tracking, and deeper space data collection. Key Indian spacecraft examples: INSET, Indian National Satellite System; IRIS, Indian Remote Sensing Program; ALUSAT, GSAT-3 dedicated to education sector. So chapter 1 is going to be end, and I hope you like this video, because that's very important for you. Like, there's nothing that is not important. You had to remember every facts and all, because somewhere it is going to be asked in any exams, like apart from UPSC. You, if you're going to give other exams too, it will help you. So yeah, just do it. Just watch it properly, again and again and again and again.